Okay, so we're going to look at ionic formula just so we can really clock year 10 chemistry. What I noticed in our pre-test, if you have a look here guys, really common mistakes, and it's not just ever one person doing it. So have a look here. This has got charges, so we're saying write formula for the compounds. When we write the final formula, so zinc oxide actually has no charge on it, no charge. Okay, but when this person has been writing, they put some charges here, and I can totally see why. It's the first step in writing the ionic formula, but when we finish it for the final ionic formula, we want to have no charges. Okay, so that's what we're going to address today, how to write ionic formula. And also let's try and get our symbols correct. So not our symbols, but our subscripts and superscripts. So these are charges over here, and if there's no charge, it means there's two of them, and that two would have to go down to the bottom. So let's have a look at an example. So simple example, sodium chloride. So write the formula for sodium chloride. So if I'm given the compound, what I'm going to do is get my periodic table. That's always the first step, because unless I know the charge on sodium and the charge on chlorine, I'm not going to be able to write the ionic formula. So sodium is in group 1. That means it's got one outer electron, and even if you didn't know it was called group 1, you could have a look at that little number 11, which means it's got 11 electrons. So I could draw it out and go 1, 2. I know the rules are there's 2 on the first shell, there's 8 on the next shell, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So far I'm up to 10. 11. That 11 means there's 11 electrons, okay? That 19 means potassium's got 19 electrons. Also means they've got the same amount of protons. So sodium's unstable because we all know that they need to have a complete outer shell. So to get a complete outer shell, sodium needs to either gain 7, or it needs to lose that last one, so that this second last shell will be the outer shell, and that second last shell is actually full, it's 8, so it'll be stable. So that's the story with sodium. Now here comes chloride, or chlorine. So chlorine, look at the periodic table, it's in group 17, or right over here. Sometimes we refer to that as group 7. It means it's got 7 outer electrons, just the same as fluorine and bromine and iodine. They've all got 7. They share that in common. So if we want to know how many completely, it's 17. 17 electrons, 17 protons. So I can go 1, 2, there's only 2 on the first shell, 8 on the second shell, 8 on the next shell. So that gives me 10, and I've got to get all the way to 17, so I've got to add 7 more. 1, 2, 3, 4, 5, 6, 7. And you can see the problem here is chlorine has got almost a complete outer shell of 8, but not quite. It needs 1 more. Sodium has got 1 that it can give away. So they make a very nice pair. Sodium will give the outer electron to chlorine, and then they are both happy, they're both stable, and they'll form an ionic bond. Okay, so that's the long way of doing it. If we want the short way of doing it, just know the charge. So the charge comes from how many electrons on the outer shell. So because we know sodium will lose 1, that means it's overall, and we know that there's 11 protons inside the middle. So 11 positive charges, or protons in the middle, in the nucleus. If we lose 1, which it does when it gives it to chlorine, it's only going to have 10 electrons. So overall, it's got an overall charge of +1. Okay? Chlorine, on the other hand, has got 17 protons in the middle, and they don't change, but the number of electrons does. It's got 18 electrons, because it took 1 from sodium. So overall it's going to have a -1. So see how when we're doing ionic formula, we completely skip the drawing step. Like once you become an expert at drawing it or visualizing it, you can go straight to just knowing the charges, and you can get that from the periodic table. So anything in group 7 is going to have a charge of -1. Anything in group 6 or 16 is -2, because they gain 2 electrons. Okay, so -2. And over here, they're +1, group 1 is +1. These guys have got 2 outer electrons, so they lose those 2 outer electrons, so they become +2. Okay, so you can get that from the periodic table. So if I were to write the ionic formula, I need to know the charges. So this could be a step towards getting my final formula, but this cannot be my final formula. You see, these become chargeless, or they don't have a charge once they become a compound. So this indicates the charge on their way to becoming that compound. So sodium is plus, chlorine is negative. They cancel each other out, and it just becomes sodium chlorine. And you can see that in the picture. Only one sodium atom is needed to donate 1 electron to chlorine.